Okay, this lesson is about improper fractions changing to mixed numbers, and likewise we'll cover mixed numbers changing to improper fractions. So to begin with, let's remember that an improper fraction means that the numerator is greater than the denominator, and that is not considered to be in simplest form or reduced terms. So we need to begin by looking at what this means. In actuality, a fraction bar means that you're doing division. So 17 divided by 6. So one way that we can solve this problem and find the mixed number is to put the 17 in a position where we can divide by 6. So now we're counting by 6s to see what we can come up with, how many 6s can we make out of 17 without going over. And if we count by 6s off to the side, we can see that if we go 3 6s is too much. So we'll stop here at 2 6s. 6 can go into 17 2 times. 2 times 6 would be 12. And when we subtract, we get a remainder of 5. Well, in a mixed number, what that means is that we can have two groups of 6. So that would equal the whole number 2. And I'm sorry it's so close. The denominator will always stay the same. It's going to stay 6 because we're doing groups of 6. And the remainder becomes the numerator. So 17 sixths is the same as saying 2 and 5 sixths. And that part of the mixed number, the fraction, is already in counting order, which means that it is in simplest form. Let's try again. We'll work with the 14 thirds. Again, same idea. We're doing 3 into 14 because that's what this means, dividing 14 by 3. So off to the side, I'll do 14 by 3. And I'll say how many 3's can I make out of 14? Well, in this case, if I count by 3's, 3, 6, 9, 12, and 15 would be too many. So I have 4 3's. 1, 2, 3, 4. 4 times 3 is going to be the 12. When I subtract, I get 2. So my remainder is 2. Okay. And I'm sorry for squeezing things in so close together. So now I have 4 remainder 2. Well, again, I'm going to have a whole number. That's how many 3's I could make out of 14 without going over, so the whole number is going to be 4. The remainder is going to be the 2, how many leftovers I had, and the denominator is going to stay as the 3. Okay, one more just like that. This time I'll try not to squeeze too far in. All right, so we're going to take 35 divided by 4, because that is what 35 fourths means. And we're going to say, how many 4's can we make out of 35? And this time I won't crowd it with all my math facts, but I'll just do it in my head. And I'm thinking right away that 7 times 4 would be 28. But then I'm thinking higher. 8 times 4? That's 32. And that's certainly going to be the closest I can get without going over. So I'm going to put an 8 up top. 8 times 4 is 32. I'm going to subtract and get 3. Remainder 3. And again, I remember, my denominator stays the same. Oh, I'm sorry, I want to draw a box first. My denominator stays the same for my fraction. My quotient is going to be my whole number, and my remainder is going to be my numerator. And so I get 8 and 3 fourths. Again, just like 2 and 5 sixths, 4 and 2 thirds, 8 and 3 fourths, we have fractional pieces that come out to be in counting order or simplest form already. Okay, so let's think of it a different way. We know that when we do 7 halves, we're going to come up with a mixed number that's going to have a whole number and it's going to have a fraction. So I put in my box for my whole number and my fraction bar for my fraction, and the first thing I do is bring over the 2. But now I'm going to do some thinking aloud. I'm going to ask myself, how many groups of 2 can I make out of 7 without going over? So I'm going to do like I did here. I'm going to count in my head. I'm going to count out loud for you today, but I'm going to count by 2's. 2, 4, 6. That's as close as I'm going to get without going over. 3 2's because it's 2, 4, 6. And that's 3 2's. So I'm going to put a 3 in the box. And now I know by putting a 3 there that I used up 3 times 2, which is 6 of the 7. So if I used up 6 of the 7, that would mean I have 1 left over. And that's going to be my numerator. Okay. Now, That works out great because, again, this one is nicely done. It's a simplest form fraction, so I'm all done 3.5. Another way that you could do that, though, is if the numbers are small enough, you could draw some pictures. You could draw 7 circles, and then you could put them into groups of 2. You could circle or square out groups of 2, as you see me doing here. And then you could say, how many groups did I make? That's my whole number. And how many are left out? That's my numerator. And of course my denominator will stay the same. Now sometimes we get a really nice situation. We get a 12/6. And something's different about it, because when I say how many 6s can I make out of 12, the answer is 2, because I know 2 times 6 already is 12. But that leaves me with 0 leftovers. Well, a fraction that's 0/6 is simply the same as 0. So we don't even have to write it. We can just stop with the whole number and we're done with the problem. Likewise over here, how many 3's can I make out of 9? I can make 3 of them with no leftovers. I'm going to use up all of the 9. So there will be no leftovers. If I had drawn this, it would look like this. And I would have made groups of 3, like this. And like that. So I'd have 1, 2, 3 groups. And there are no leftovers. Now, finally, where we're talking about improper fractions to mixed numbers, we might have some problems that look like these two. Okay, let's think about how they're different. Right now, same idea. We're going to get that. We're going to bring over the 4, and whatever method you get, you're still going to come up with this kind of answer. And you're going to say 4 goes into 4, I can make how many groups of 4 out of 14 without going over 14. If I count by 4s, 4, 8, 12 is as close as I'm going to get, and that's 3 groups of 4. That's my whole number. But if I make 3 groups of 4, that will be 12, and there will be 2 leftovers from the 14. The difference here is I had simplest form fractions up here, but now I do not. So I have to go to simplifying. And by simplifying, I'm going to make these into equivalent fractions that are the smallest they can be by dividing the numerator and denominator by the same number. In this case, it'll be 2. So 2 divided by 2 will equal 1, and 4 divided by 2 will equal 2. And so the final answer will be the 3 and the 1/2. And that's in simplest form right there. And likewise, we're going to look at this one in here. Again, you wouldn't want to draw 26 circles, but you know what? If you didn't know the answer, you could always do it and it would work. In this case, you could also divide. You could just go over to the side and say 26 divided by 4. I know that 4 times 6 is 24, so that looks like it's awfully close. I have a remainder of 2. So over here, I'm just going to bring my 4 over here. I'm going to put my 6, which is my quotient, as my whole answer, my whole number, and then I'm going to put my 2 up here, and I notice that I have 6 2/4. Likewise, I would want to simplify, so I would end up simplifying this to 6 1/2. There we are. Now in doing mixed numbers to improper fractions, a little different. This time, we're going to do 2 processes to find the answer with 1 extra little step. Now we're turning this into a fraction. So in each case, there is going to need to be a fraction bar. There will not be a whole number. And we're going to do multiplication and then addition. And the easiest thing to remember is that this is going to stay the same. If the denominator was a 3 here, it's going to remain a 3. If the denominator here is a 2, it's going to remain a 2, and so on and so forth. When turning a mixed number into a fraction, use the denominator that's there, because that's going to be the denominator of the new number. And in order to find the numerator, you have to do 2 things. It's kind of the reverse of what you did up there. So, first you're going to multiply. You always start at your biggest number. That's your whole number. It's larger than the other numbers. It's sitting out in front by itself, and it's going to get multiplied. So it's going to multiply against the denominator. And 3 times 3 equals 9. Then, to that answer, that sum, you're going to add, that product, you're going to add the numerator to the product and find the sum. 9 plus 2 is 11, and that's the number that is your numerator. So it's a two-step process after you've written down your denominator for the new fraction. Again, same thing here. First things first, 6 times 2. That equals 12. Then you're going to add the 1. That's 13, and that's the answer. And finally, these last two, 2 times 4 equals 8, plus the 3 equals 11. And finally, 5 times 6 equals 30, plus the 1 equals 31. Now what's really fun is if you do them backwards, like we did up here, that's the way you can check. Because if you look at 11 thirds, and I'll do it right out here, 11 thirds, 11 divided by 3, 3 times 3 is 9, with a remainder of 2. And look, 3 is the whole number, 2 is the numerator, 3 is the denominator. It works out just fine. So that's how you can check. You can check your improper fraction if it's correct by going back and forth. It works out great. So there you have it. I hope you've enjoyed this, and if you need it, I hope it's worked for you.